Heatwave, a team of 5 seniors tasked with designing and creating a portable cart with an intricate system meant to measure the heat flux off of a given test sample by way of simulating actual and reasonable fire conditions. Heat flux is a critical factor in determining material ignition and spread of fire and assessing structural responses to fire. For structural components subjected to a fire condition, the method we previously used is to apply heat flux to the specimen first, then the specimen is subjected to any structural integrity testing later, separately from the heat flux. This method is not realistic as actual structural components are subjected to both structural loading and heat at the same time in fiery conditions. Our aim is to investigate the responses of structural and non-structural building components. Using our design, the same heat flux measured from the actual fire can be regenerated and applied to any structural building components while they are under various tension, bending, or compression forces. After much deliberation on which design to choose, our team went with this design of a pre-built push cart that allows for vertical movement by way of a foot pedal. Welded to the cart are 2 linear rails connected by a ball screw, controlled by a motor that allow for 2 mounted heater panels to be moved back and forth horizontally. This fabrication process included soldering, using the water jet, and welding, as well as milling parts of the materials. The cart is able to move horizontally in 2 different ways. The first way is through the basic transportation of the cart by pushing the cart on the 4 caster wheels. When the cart is set in place and needs more minor adjustments, the ceramic heater panels are moved horizontally through the ball screw. A Raspberry Pi is connected to a stepper motor which, in turn, gives power to the ball screw that runs the length of the cart. The ball screw is connected to 2 linear rails through 4 contact points that provide a base for the connected ceramic heater panels. As for vertical movement, to lower the cart, a handle lever is located on the top of the back handle that you need to squeeze to slowly lower it. To raise the cart, there is a foot pump located in the back of the cart that you need to pump up and down to incrementally raise the apparatus. The electrical side of the cart has several components that must be run together for the apparatus to work. The motor that controls the ball screw is connected through a stepper motor driver which helps the motor move forward precisely. This driver is then connected to a Raspberry Pi, a small, portable computer, which controls every bit of movement on the apparatus, including the power converter from 24 volts to 5 volts, as well as the thermistor. The Raspberry Pi has a calibration and data collecting program on it to be run once the apparatus is started. The thermistor is used as a sensor to detect how hot the ceramic panels are getting. As the ceramic panels warm up and cool down between testing phases, the Raspberry Pi analyzes the temperature value and determines how the apparatus will behave based on a preset list of values. Here, we tested the thermistor by recording the temperature of a standard kitchen oven. With our cart fully built, here we are testing the apparatus as a whole and igniting the propane to get the ceramic panels heated up. Heatwave, igniting the future of heat flux technology.